Hi, welcome to our video tutorial that will discuss Maxwell's mesh method. This is one of the network laws and theorems that we will be discussing in solving circuit diagrams that cannot be solved by Ohm's law alone. So after Kirchhoff's law, we have this Maxwell's mesh method. So how is it done, or how is a complex circuit diagram solved using this method? So first step, we will assign mesh or loop currents to the loops found in the circuit. Then apply KVL, and then using your algebra skills, you will solve the resulting simultaneous equations. So I think you can use your calculator to solve for at least 3 unknowns, or at most 3 unknowns, but with 3 equations. So let's proceed with an example. We have this circuit diagram. Solve for the voltage across the 6 ohm resistor using mesh method. So for mesh method, it's like a shortcut for KVL. Instead of assuming for current direction in each resistor, look for the loops and name those loops as loop currents. So if, for example, in this example, we have 4 resistors. If we are to use the Kirchhoff's laws, we will end up with 4 equations, or 4 unknowns, and then 4 equations. But using mesh method, look for loops. Let's say we have this loop, this closed path. I will name that loop X with direction clockwise. And then this loop also, this one. Can you clearly see that? This is also a closed loop, and I will call this loop I'll call this loop I2. Let's just rename this one as I1. I will name that as loop I1 because it is said that you name loop as loop currents. So this is loop I1 and this is loop I2. Then you form the KVL equation. So let's form the KVL equation at I1. But listen carefully, how is it being done? For I1, it passes through first this voltage source 3 volts, and as you can see, the I1 in this loop enters the positive, then leaves the negative. That would be a negative 3 volts. Negative 3. And then it passes through this 3 ohm resistor, and since the current assumed in this 3 ohm resistor is your loop I1, and I1 is the same with I1, of course, it's itself, that would be a negative. So that would be always a negative 3I1. Now, for the twist for this 6 ohm resistor, the loop currents, this is mesh method, the loop currents that passes through the 6 ohm resistor is the loop I1 and loop I2. Now we are forming the KVL equation for loop I1. Since I1 is the same with I1, that would be a negative 6I1. How about for I2? Now, for the IR drop with respect to loop current I2, you need to know the direction of I2, with regards to I1. So for I2 on the 6 ohm resistor is to the right, right? To the right. But your I1 is to the left. That's why, since I2 is in opposite with I1, which is our point of reference here, so that would be a positive, opposite direction. 6I2 then equals 0. Simplifying the equation, we will have 9I1 plus 6I2, or minus 6I2, rather, I'm sorry, minus 6I2 equals negative 3. 9i1 minus 6i2. Then divide both sides by 3. We have 3i1 minus 2i2 equals negative 1. This will be our equation 1. How about for equation 2? Then let's form for the KVL equation for loop current I2. KVL Ay, sorry. KVL at loop I2. So, where shall we start? Let's start with the voltage source here. It enters the positive, then leaves the negative 12. That would be a negative 12. Next, it passes through this 2 ohm resistor. And the loop current that passes through this resistor is only the loop current I2, which is the same with our point of reference. That would be a negative 2i2. Then it passes through the 6 ohm resistor. Spot the difference. Now our point of reference is I2. And again, the loop currents that passes through the 6 ohm resistor are loop currents I1 and I2. So I2 with respect to I2, that's just the same. That would be a negative 6i2. Now, there's also an I1 that passes through this resistor. And observe that I1 on this resistor is to the left while your I2 is to the right. It's opposite our point of reference. Therefore, that would be a positive 6i1 equals, oh no, we're not yet done. Then our loop I2 passes through this 2 ohm resistor. It's the same with our point of reference. That would be a negative 2i2. Then with respect to this voltage source, it leaves the positive terminal, or it enters the positive, then leaves the negative. That would be a negative 8 equals 0. Simplifying the equation, we will have 6i1 minus I2. Negative 8 minus 2, that would be a negative 10i2. Then transpose all the constants to the other side of the equation. We would have negative 12 minus 8 equals 20. Divide both sides by 2. We will have 3i1 minus 5i2 equals 10. This will be our equation 2. Simultaneous equations, 2 unknowns, 2 equations by calculator. We will end up I1 is equal to, and I2 is equal to. We have I1 equal to negative 2.78, or in fraction form, that would be negative 25 over 9 amperes, and I2 as negative 11 over 3 amperes. Now we haven't solved the problem because we have to solve for the voltage across the 6 ohm resistor. So we need for the current that will pass through the 6 ohm resistor. So again, as you can see from this resistor, the loop currents that passes through this resistor are I1 and I2, right? So I6 would be what? As you can see, I1 is to the right, while I2 is to the left. They are of opposite sign. Therefore, the current that passes through the 6 ohm resistor is the difference between the two. And when you solve for the simultaneous equation, your I1 is negative. Therefore, we have assumed a wrong direction for loop current I1. And I2 is also negative. We also assumed a wrong direction. So it must be a counterclockwise. But anyway, that's okay because the value is, or the magnitude would still be the same. So again, for I6 would be the difference for I1 and I2. What will we, or I2 minus I1? Let's just say it's I1 minus I2. If we will do that, this will be equal to, this will be equal to 8 over 9. It's positive. Now what we did, we equated I6 as I1 minus I2. Therefore, we are following the direction of I1 as the direction for the current on the 6 ohm resistor. And since we resulted on a positive, therefore, it is right that we assumed for the direction of I6 as the same as I1, which is, from the figure, we assume that I1 is to the left. Therefore, our I6 would be 8 over 9 amperes, which is to the left. And to solve for the voltage across the 6 ohm, that would be I6 or 6I6, which is equal to, that will be 5.33 volts. And that is our final answer. So next example, we are to calculate for the current that passes through the 12 ohm resistor. Now guys, if you are to solve this using Kirchhoff's laws, we will have 5 resistors, then we will end up with how many? 5 unknowns. So we need to form 5 equations. That would be very complex. But using the mesh method, first, what to do? We just need to form the loops and name these loops as loop currents. And let's choose this closed path. And then let's label this as I1. And then I will counterclockwise. I want to make that as a default so that there will be less difficulty in forming the equations with correct signs of voltages and currents. So this closed path, I will also name this as I2. Okay, the next to that is to form the KVL equation on each loop current. So forming the KVL equation for I1, let's start with this voltage source. It enters the negative and leaves the positive. So that would be a 36 positive. Then it passes through this 2 ohm, and our point of reference is I1, and the loop current that passes through this 2 ohm is also I1. That would be negative 2I1. For the 12 ohm resistor, there are how many loop currents? The loop current I1 passes through this, and as well as for the loop current I2. So for I1, since our point of reference is I1, that would be negative because they are the same. So that would be negative 12 I1. For I2, now I2, with respect to I1, is it the same direction or opposite? So for I2, loop current I2, it's upward. But for I1, it's downward. It's of opposite sign. Therefore, that would be a positive 12 I2. Okay, but this is for loop current I1. Now, what's next? After this 12 ohm resistor, it passes then to this 4 ohm resistor. And our point of reference is also I1. That will be a negative again. Negative 4 I1 equals 0. Simplifying the circuit diagram, we have negative 2 minus 12, negative 14, minus 4, negative 18. I1 then transpose to the other side of the equation. That would be a positive 18 I1. Then transpose this positive 12 I2 to the other side. That would be a negative 12 I2 equals 36. As long as uh, our voltage or the equation of our, or the form of our equation is the same with the calculator, unknown, then constant. I don't want to simplify that to avoid any carelessness or mistakes. So this will be my equation 1. Equation 1. For equation 2, I will form the KVL equation for loop I2. KVL at I2. So I will start with this negative 24 or this 24 volts voltage source. It enters the positive, leaves the negative, that would be in negative 24. What's next? It passes through this 3 ohm. Our point of reference is I2. So this will be a negative 3 I2. And then to this 12 ohm resistor, I2 is the same with I2. That would be a negative 12 I2, our point of reference. Now, I1 with respect to I2. I2 is upward, but I1 is downward. It's opposite. Therefore, that would be a positive 12 I2 or positive 12 I1. And then our loop current I2 passes through this 9 ohm resistor. Our point of reference is I2. Therefore, that is negative. Simplifying the equation, 12 I1, first unknown, then second unknown. This would be negative 3 minus 12, negative 15 minus 9, negative 24, I2. Transpose our constant to the other side, that would be positive 24. And this will be our equation 2. If you do not know how to use the calculator, guys, in solving simultaneous equations, and for this example, 2 unknowns, then search for tutorial videos so that our solution will be minimized and be more accurate. So this is our equation 2. Using calculator, we will have I1 is equal to and I2 is equal to. Solve this using your calculator. We have I1 is equal to 2 ampere and I2 is equal to 0 ampere. Now we are asked to solve for the current that passes through the 12 ohm resistor. As you can see, for the 12 ohm resistor, there are 2 loop currents that passes through this. We have I1 and I2. And as you can see, I1 is downward while I2 is upward. Therefore, I12 is the difference. But guys, if they are of the same direction, let's say, for example, you want to solve this, but you don't want to follow my direction for the loop currents, and it will end up that your I1 and I2 with respect to 12 ohms is the same, then therefore, the current that passes through your 12 ohm is I1 plus I2. But for my assumption, I12 is I1 minus I2. Of course, 2 minus 0 is just 2 amperes. And what's the direction? Since we have I1 minus I2, therefore, we have here our minuend as I1. Therefore, I'm following the direction of I1 to be the direction of my I12. So the direction of our I12 is downward. Now, we have solved the problem. So for the next example, we have here this circuit diagram, this one, and we are to solve for the unknown using mesh method. So far, we have solved for circuit diagrams with voltage sources only. But how about for this one? We have here a current source. So how are we going to solve this type of problem where there is a current source but using mesh method? For this example, we are to solve for the current that passes through the 6 ohm resistor. So for the first step, this is case 1. For the first step, we are to form loops and name them as loop currents. And next to that is to form the KVL equation. But take note, guys, for this closed loop, we name this as loop I2. Loop I2, right? And as you can see, for this series branch, with our assumption, this is the current or loop current I2 that is, or with direction clockwise. But in our given, it says here that this series branch, the current that passes through this is this 5 ampere current source. And it's pointing upward. But on this branch, I2 here is pointing downward. Therefore, we will get I2 as equal to negative 5 amperes. So that will be our equation 1. And for equation 2, we will do the KVL at I1. Let's start with the 10 volts. Now you guess what is it? That would be a positive 10. For this 4 ohm resistor, that will be minus 4I1. For this 6 ohm resistor, as you can see, there are two loop currents that passes through this. We have I1 and I2. For I1, our point of reference is I1 also, so that would be a negative 6I1. For I2, our assumed I2 in reference to I1, that is upward, but our I1 is downward. So that would be a positive 6I2 equals 0. Simplifying the equation, we will get 10I1 minus 6I2 equals 10. And this will be our equation 1. Or since this is just easier to solve, we will just substitute I2 as negative 5 amperes. So let's do that here. Wait, 10I1 minus 6 times negative 5 equals 10. Therefore, we have I1 as 10 plus minus 30. We have here I1 is equal to negative 4, 2. 10 minus 30 divided by 10. We have here negative 2, so the assumption for I1 is wrong. Negative 2 amperes. Now we are to solve for the current that passes through the 6 ohm resistor. So 6 ohm resistor, our I1 is negative. Our I2 is also negative. Now, what I am going to do is try to correct for the directions of I1 and I2 with respect to the 6 ohm resistor. So our I2 is negative 5 amperes. Therefore, with respect to the 6 ohm resistor, my I2 is downward. Right? But my I2 is downward and I1 is also negative 2. So therefore, I1 with respect to this resistor is upward. So up I1 is upward, I2 is downward. Okay, so for I6, no, I1 is upward, 2 amperes and upward, while my I2 is 5 amperes and it's downward, which is bigger. I2 is bigger. Therefore, our I6 will be equal to I2 minus I1, which is equal to 3 amperes, and it follows the direction of I2, which is downward. So that's how you are going to solve mesh method to circuit diagrams with current source existing only in one mesh. Now for case 2, solving circuit diagrams using mesh method, but our circuit diagrams have current sources existing between two meshes. So we have this mesh, that one, and this one. There exists this current source 6 amperes. We create a super mesh by excluding the current source and any elements connected in series with it. That's why from the figure shown, we have this series branch, exclude this as you form the KVL equation on the loop. So here we have this mesh 1, we named that as loop current I1, and then this mesh 2, we named this loop current I2, but in forming the KVL equation, actually we can also do the KVL equation on this super mesh, and I will call that super mesh as mesh X, this super mesh. I'll change the color for that one so that you can clearly see it. That closed path, I will call that as super mesh X. Now, in forming for the KVL equation for the mesh X, just follow the same steps. Mesh X passes through this positive or this 20 voltage source, enters the negative, leaves the positive, that would be a positive 20. On this 6 ohm resistor, as you can see, only loop current I1 passes through this. And loop I1 is the same as your loop X. Our point of reference is our super mesh X. They have the same direction. Therefore, that would be a negative 6I1. Next, our super mesh X passes through the 10 ohm resistor, and the only loop current passing through this resistor is our loop current I2, which is in the same direction as our loop X. Therefore, that is still a negative 10I2. Next, it passes through this 4 ohm resistor, minus 4I2 equals 0. Simplifying the circuit, that will be 6I1 minus 14I2, or plus rather, plus. Transposing these terms to the other side equals 20. That is our equation 1. And since we have two unknowns, I1 and I2, but we only have one equation, what will be our third equation? So for our third equation, we will do a KVL at this loop. Let's name that loop as, or node. Let's name that node A. So forming the KVL, no, not the KVL, but the KCL at node A, loop current I1 is entering node A, right? I1 is clockwise and it's entering node A. So we have here I1 as entering. How about for 6 amperes? This 6 ampere. This is the current that passes through this series branch or this branch. So 6 ampere is also current entering, the same as I1. So that would be plus 6. And for I2, that is uh, with respect to this node, that is leaving node A. So that would be equals I2. And because I want to use a calculator, I will modify this equation. I1 minus I2 equals negative 6. And that will be my equation 2. Using your calcu, you will get I1 is equal to, and I2 is equal to, I1 is negative 13 point, oh no, I1 is negative 3.2 amperes and I2 is 2.8 amperes. Now, if you are to solve for some unknowns, at least you now have the values of the loop currents I1 and I2. So that's it for Maxwell's mesh method. Thank you for listening and have a good day.